This question is parametric equations, and it's talking about the gradient of the curve, which means we're going to need to find dy by dx. Now, when you've got parametric equations, dy by dx is dy by dt times by dt by dx, and you can see here that dt's would cancel to leave you with dy by dx. Another way of saying that is dy by dt divided by dx by dt. So essentially we've just got to differentiate x with respect to t, differentiate y with respect to t, and then we'll divide them with dy by dt being on the numerator. So dy by dt, let's do that first. That will be 3 plus 4 sine t, and then that will be minus 2 cos 2t. So that will be on the numerator. The denominator is the derivative of cos t minus 3t. That will be minus sine t minus 3. So that's what dy by dx equals. Just write that out again over here. 3 plus 4 sine t minus 2 cos 2t over minus sine t minus 3. So that is the gradient of the curve. Now somehow we need to show that all of this is negative. How are we going to show that all of this is negative? Well, we need to show that either the numerator is always positive and the denominator is always negative, or the other way around. Just by looking at this, I think you can see that that denominator there, if we just look at the denominator, sine t is always between minus 1 and plus 1. So since sine t is always going to be between minus 1 and plus 1, when you take away 3 from any value in this range, it's going to be negative. So therefore I think we can say that therefore the denominator is always negative. So the question now is, how are we going to prove that the numerator is always positive? Well, that's a bit more awkward. Looking at this numerator here, how are we going to show that that is always positive? It doesn't look obvious from the question, does it? So I think it might be a good idea to try getting rid of that cos 2t and getting that in terms of sine t, and then we might be able to complete the square to show that everything will be positive. So let's see if we can do that. If we just clear a space over here, let's do this in a different color. Okay, so we're just looking at the numerator. Now. Okay, so if we put that up there, we can replace the cos 2t with 2 sine t plus 1. So that means, sorry, I do apologize, that's absolute rubbish. I'm looking at the wrong thing. If we replace cos 2t, that would be 1 minus 2 sine squared t. So then we need to simplify all that. So multiplying out the brackets will be -2, and then we're going to get plus 4 sine squared t here. 3 minus 2 is going to give us a 1. Now this is looking promising. If we just write this in this order, that looks like it will factorize. I'm pretty sure it will factorize to give us this, which is good news, because whatever this equals, positive or negative, when you square it, it will make this always positive. So that means that the numerator, that means that the numerator, which is this, is always positive. So then if we got positive numerator, negative denominator, we can finish off the question by saying, therefore dy by dx, which is the gradient of the curve, is always negative, because you've always got a positive here divided by a negative.